Um, so we start from the top. So in this notebook, we're going to be exercising one of the skills you've learned in session 5, which is transfer learning. And just to give a quick recap, a very basic explanation of what transfer learning does. It's essentially just a way for you to use a pre-made model that someone else has already made and use like most of the layers from that model and then add like your own layer like on the last one just to customize it for your specific project. And we use this thing called freezing layers so that we can freeze all the convolutional base that we don't want to use. And then finally on the last layer, we can customize it for our specific project. And for those who were like not there last class or kind of forgot what we did, we just spent the whole 1.5 hours learning how to tune hyperparameters and how to essentially improve your neural network so that like your accuracy can go up. And like last class was probably a bit boring because it was mostly lecturing, but again, this class is everything's going to be hands-on and you're going to see projects, like you're going to actually be able to see the project. So there's a couple of things. The first thing is feature extraction. And so like the convolutional neural network already like extracts these features, how kernel and how it works. But specifically for convolutions, there's a specific kernel that is multiplied by each segment of the image to derive like a smaller form of the image. And then we always perform pooling after that so that we can get a bigger version of that. So we're just going to be using multiple convolutional and pooling layers in this model. So let me first look at the chat messages. Okay, sorry, I was chopping off. Could you guys please tell me where I kind of broke off? Okay, yeah. So yeah, I was just talking about how the convolutional neural network is automatically going to be extracting the features for us. So we don't need to use like a manual feature extraction technique. We only need to add the convolution and the pooling layers in order to perform that well. And then we also learned about fine tuning. Again, that's just unfreezing like the final layer because we're using transfer learning in this model. So it's only unfreezing the final layer and freezing the beginning few layers so that we can keep like the pre-used model we're using. And you can read these descriptions in more depth, but I'm just giving like a base explanation. So here are like the steps that like you usually do in a certain machine learning project. So the first thing we're going to do is just install the basic libraries. Of this sort of class or this workshop is not to focus on data pre-processing. It's more like how do I create models? How do I understand how they work? What are the different models? So I'm not going to be going in depth in any of these like pre-processing techniques, but I'll still explain them briefly. So the first thing we do is first download this. So this is the data set is stored on Google's like API website thing. So you can just access the website from there, and you have to use this tf.keras.utils get as a zip because it's initially a zip. So all this over here is all it's doing is basically just getting the data set and storing it into our respective train and validation directories. So if you remember, we always have like a train and a validation. And sometimes we may choose to not have a test because the validation can basically be a test set. So usually when someone says they only have a train and a test set, that's actually not true. It should be like the proper terminology would be a train and a validation set. Because you can usually never have a project that does not have a validation set. Otherwise, it's not complete. And this is so using pre-processing technique to and we just specify the parameters. So the first thing is the training directory that we got from here. And we use this OS module that essentially allows us to add the path, so our current path, and it adds it to the train. So we can store the training directory in that. And so we do that for the training data set, and we do the same thing for the validation data set. So you can run both of these two cells. And then here are like the different 9 images, and you can see they're either cats or dogs. So if you were to run this, Let me just run this myself, actually. So I run this. And a helpful thing you can always do is go to runtime and change the runtime type to GPU. I already have GPU set, but that's usually what you want it to be. That's weird. I forgot to run the imports first, my bad. So you always want to make sure you run the imports because you can see it's saying, oh, TF is not defined. And TF just refers to TensorFlow. So we want to first import. And TF nightly is just going to be a package we use throughout this project. It's not going to be used that prominently, but it's a thing we're just pip installing. Okay, so here is when we're downloading the data. And this is the validation set. And then these are the different like first 9 images we can see. And we're just plotting them. And again, this is like the data pre-processing stuff, so I'm not going to go in depth in this, but you can always refer to the documentation on TensorFlow and Keras if you're interested in what these things do. But this is essentially just creating the different batches for the test and validation set. This is just printing the number of batches. Okay, so for you here, so this is like an official tensor they add on there. And I would call it this optimized bit using autotune, and this is for more advanced like IO connection related stuff, and we're not going to be using this that much. So if you choose to not run this this like code segment, then you do not need to do that. So like, do not worry if you're confused about what any of this means. This is just a way for you to make sure that your model is ready for production and that it's like not encountering any IO errors. Okay, so this is some data augmentation. So if you remember last class, I explained that one way to prevent overfitting is by adding data augmentation, which is essentially adding random images. And so there were different ways we can do that. So in this case, so there's different ways that you can actually add data augmentation. In this case, we're just adding a sequential model and adding individual layers inside of here, like pre-processed. The image to rotate it. And as using training, they're not okay, so if we apply those layers to new set of images, so if we apply this pre-processing to these new images, we can see that okay, yeah, I think I just have a lot of stuff on my computer, which is why I'm cutting off. Okay, so what I was saying here is essentially, can you guys hear me all right now, or am I still cutting off? Okay, so what we want to do here, and this is giving an error because I didn't run this yet. What we're doing is we're just flipping the image horizontally, and we're rotating the image with a factor of 0.2. So it will rotate 20%. And last class, we covered how to essentially flip images and how to rotate images using some of Keras's pre-functions. And in this case, we're just using a sequential model with different layers. And this is an important note to take into account. These layers are only going to be used during the process. But in the final process, like in the validation, we're not going to be performing any data augmentation. That's just not perform like data augmentation during the actual like testing of the model. Okay, so let me just run this, just adding all the layers. Okay, and now when we run this, we should see like the new images. Okay, so this is, yes, you can see there, like this is just taking one image and seeing how it's been augmented. So this is a good example of seeing how data augmentation works. So now I think I'm actually going to skip to like the main part of the model, but these are just extra steps, as I mentioned last class, that you can use to improve your model. But I just want to get to the meat. So this is just extra pre-processing for rescaling the pixel values. If you remember, I told you guys about how normalizing the inputs can help. So this is what we're doing. We're pre-processing the inputs using this mobile net application that Keras already has built in. And now we just want to create our base model. So we want to, this is like our pre-trained convolutional net that Google has developed, and it's called Mobile Net V2. And you can see here, it's been trained on 1.4 million images and 1,000 classes, which means it has been like completely validated and it looks like it's working well. So we first want to load that base model into a variable. And just gonna wait for that to load. And then we want to make sure we freeze the convolutional base. And I'm skipping over a few things that are not as important. I'm just trying to get to the main meat of it. If you're interested, you can always read the description over here, or you can search up online of how certain things work. But again, the focus of this class is just to explain how like the actual model works and what you do to make the actual model. So now we want to make sure we make it such that the base model, that the trainable property is set to false. So we want to freeze them. This is how you freeze. And essentially freezing, if you remember, basically tweaks its weights accordingly after every time it attempts to make a pass over the training set. It has to tweak its weights. And what this does is it says we're not going to tweak any of the weights of the base model. We're only going to be tweaking the weights of the extra layers that we add. So now once we've set this to false, you want to see like what does the summary look like. It's not super important, but I'll still run it. Okay. And you can kind of see like the different layers if you're interested. Like it has batch normalization, which we didn't cover. You don't need to worry about that. And like depth-wise is also something you don't need to understand. But you can see a lot of the common layers like conv2D, which is the convolutional, or ReLU. And this is just like the pre-made model Google's made for us. And it has like a bunch of extra stuff. Yeah, this is where I was. And you can see that it says non-trainable parameters because we're not going to be training any of these parameters. These already have weights that have worked well historically, which is why we're going to keep them that way. So this is just adding an average pooling after. So we want to essentially add a couple layers after this base model. And so this is essentially what the code over here is doing. And this is essentially chaining our data augmentation, like methods we had above. Sorry, I think I have to run. Oh yeah, so these two were not run by accident. Yeah, I will be sharing, I'll send a link to you guys so you can access it. But you saw that error earlier because I did not run these two cells. You want to make sure that you run everything. So I'm just going to run this. And actually, to make this easier, I'm just going to run all the cells and then like see the output while I explain. I think that'll be the best way to do this. Okay, so let me scroll to where I was. We're adding the class of adding a dense layer. This is the actual prediction. You can see. Okay. And so this is chaining everything together. And we're also adding dropout. If you remember, we had that factor of dropout that lets us cancel some nodes. So we add this layer of dropout over here. And this is when we're actually compiling the model. So here you're going to see I used Atom, and Atom is like the most common optimizer that usually works pretty well, which is why we're going to be using Atom, and the loss we're using is binary cross entropy. This is just an extra parameter, which I'm not going to go in depth. It's not necessary, but you just need to understand that binary cross entropy is the loss we're using, and this is the optimizer we're using. And base learning rate. Useful, sometimes not, but it helps us customize our model easier. So we can tweak this and see how our model changes accordingly. And we're accepting the accuracy metric. And then this is what our model looks like now. So we've added like mobile net thing. Okay, yeah, so we added the mobile net like initial thing, and then we added a few layers on top of that. So we initially had this mobile net. So we actually start off with the sequential, which is where we had all the data pre-processing. And then we have this mobile net, which is that pre-trained neural network with a ton of parameters. And then we have these extra layers that we put on top of that. Okay, so you can see that we're just training the model now, and we're going to eventually get a 94% accuracy. And so you've already learned how to fit the model and do all this stuff. And so I'm just briefly recapping everything. And in the next project, you're going to be able to actually do some of the code yourself. Okay, and then this is just like printing all the accuracy, and fine tuning is just a way to make our model even better. So if you want to read all this in depth, please go ahead. I'll send you the shared link to the notebook, and I'll give you guys a viewed version so that you can edit it. You can make a some of the things working together to make a model with 94% accuracy, which is very high for like a machine learning model. And you can even do better than that if you add more fine tuning, if you tune the hyperparameters, if you add more layers on that pre-trained transfer learning model. That's essentially how you can create that. So, okay. So I sent the link in the chat. This is the link to the notebook. So I know that was like a lot of information. So like, and some of the stuff you probably did not understand. But I just want to ask you guys, do you have any questions about like the freezing layers and like the actual adding layers on top of the stuff, compiling the model, fitting the model, like all the important steps? Did you have any questions about that? Like, is it making more sense to you? You can just let me know privately in the chat. And if you had like absolutely no idea what just happened, we're going to be doing another project. And in this project, you'll be able to actually do the stuff yourself, like create a few lines of code yourself, and then I'll go over that in a second. So I just need to share. The book is essentially going to be a horses versus humans classifier. So we just learned how to classify between cats and dogs. But there's another, so cats and dogs is probably one of the most common and popular like machine learning things, I would say, or tasks or problems for beginners. But there's another popular one, and that's horses versus humans. So just gonna open it up and share it with you guys, and I'll give you all 10 minutes to work on this one. And so wherever in the notebook that it says like your line of code. Okay, so I sent a link in the chat. So the first link I sent was for like the notebook we just covered, and the second link is the notebook we're currently doing. And so for the second notebook, I gave you guys an editing version of it. Could you please just make a copy of that and like do not actually edit this project, and instead just make a copy by going to File and save a copy in Drive, and then work on top of that. So I'll give you all till 12:40 to work on that, and then we'll reconvene and go over that. And once I finish that, Yuvraj will take over. There's one other project I wanted to show you guys about flower classification, but we're not gonna go in depth about that today. I'll still send you the link to the notebook if you want to go in more detail. And at any point of time, like if you're just confused about something, just make sure you message me in the chat. Or if you want to learn more and like get more resources, you can always send an email to workshops@girlscomputingleague.org. Okay, so we have about 5 more minutes. If you are done, just message me privately in the chat. Or you can just message everyone if you'd like. Okay, so I'm going to resume now just because we have like a second part of the session that Yuvraj is going to teach. So I'm just going to go over the solutions to the notebook. And so like some of you have like told me, oh, there's like a few problems, like I'm not sure if I got everything right. And like before I go over the solutions, I just want to explain that like a lot of this is probably like foreign stuff to you, and it's going to take some time to get used to it. And the goal of like this workshop is not to teach you how to memorize the code, even though like it probably will help in you memorizing the code. It's more like for you to understand how machine learning works. And then like once you understand how it works, then you can like search up on like on Google, like how do I do a certain thing? And you'll be able to understand things much better if you already have like a basic understanding. But hopefully by like the end of like today and tomorrow, you'll be able to get a basic idea of how to create a basic project. And always remember, like you can always access code on GitHub or like online on the documentation. Like the TensorFlow documentation is great. So those are both like great resources for you to just find solutions to certain problems. Okay, so with that being said, I'm gonna go over the project. So the first thing we do in here, we're basically just downloading both these data sets locally. So the data set's called horse or human. And this guy named Lawrence Moroney, he's like a pretty popular guy. He's made a few courses on Coursera. And he essentially made these data sets. And so and they're actually, they're not real life data sets. Like they're not like the data is not real life images, even though it does look like real life images. I think he did like a bit of manipulating images off the internet and creating his own images, which is just a fun fact. But this wget no check certificate, this command is always useful if you ever want to download something. And actually, that just reminded me, if you ever want to get data sets or you don't know where to find data sets, kaggle.com is a great place where you can find data sets and you can just search for data sets on there. And once you find a data set, they usually have this, like once you find a data set, you can honestly just search on YouTube, how do I connect a Kaggle data set to my Google Colab notebook, and you'll find all the details for that. So don't worry if like you're not sure how to do that. YouTube has some great tutorials on how you can connect both of those together. So again, this is just downloading the horse or human like training set, and this is a validation set. And we're assigning those both to this temporary directory. So this one is for the just the training directory, and this is the validation directory. And then all this stuff is zip file related stuff. So since these are in the form of zip files, we have to make sure we extract the actual contents of the zip file, which is why we have to perform all these operations like extract all the items within here, and then store it in like, and then access like the local zip again and use these commands. And these are actually things you just copy and paste into your project. You don't even need to memorize the syntax. So it's like fine if you had no clue what this does. I mean, no clue like how to do it, but you should still know what it does. So with that being said, this, what it does over here is we're essentially creating our different directories. So the first directory you create is for the horse and the train. So these are horse images with train, like the training images for the horses. This is the training images for the humans. This is the validation images for the horses, and this is the validation images for the humans. So we're just splitting it into 4 different directories. And so I don't think you had to do, I don't recall exactly what code you had to write, but I'm not sure if you had to write anything in here. So then we import TensorFlow. We're only going to be using TensorFlow. This is a much more simplified version of the notebook I went over last time. That included a lot of pre-processing and some code you didn't understand, but hopefully you understand what TensorFlow is by now. It's just a library that allows us to make machine learning much easier rather than writing it purely in Python, even though writing in Python is pretty cool, like from scratch, but it takes like a lot of code. So this is importing TensorFlow, and now this is just creating our whole model. And so I'm pretty sure I allowed you to like customize and write your own like layers and stuff you want to do. But the main idea is we just add a bunch of these combinations. So a conv2d layer, which has 16 units, a 3x3 kernel, and a ReLU activation function, and it accepts an input shape of 300, 300, 3. And then we have a max pooling layer of 2x2. And we essentially duplicate this multiple times, maybe change the number of units we want. And we don't need an input shape here since only the first layer requires an input shape because the images are 300 by 300 and have 3 different colors, RGB. So that's just creating the layers. It looks like we do 5 of these convolution plus pooling layers. That's usually a pretty good amount. That's most of the time you want to use transfer learning. In this case, we're not doing any transfer learning, but I just wanted to show how to make everything from scratch without using someone else's model. Okay. Oh, okay, yeah. So Kavya, that's actually a great question. So Kavya asked, how do you know how many units there should be by layer, like per layer? And the real answer is you actually never know. A typical amount people use is just a power of 2, so 16, 32, 64. And you really just need to play around with these layers. But generally, what I would advise is complex sort of computations as it advances the chain of the neural network. And this is proven to be a pretty effective strategy. But realistically, you never know the right amount, which is why you would use that H params thing I mentioned. If you remember last week in last class, I talked about using the H params dashboard, which allows you to modify hyperparameters and stuff. And so if you were not sure how I could determine the exact number, you could always use that H params dashboard. And if you want access to that, or if you were not able to find it, then just let me know and I can send you that notebook. You can also find that information on the TensorFlow documentation. So yeah, Kavya, it's a great question. And just to keep it short, you would just, you never actually know, but generally you want it to increase and you want it to be powers of 2. Okay. And you can see we're using a ReLU activation, and that's usually the most common activation you can use. There's others like softmax and sigmoid and tanh, but we're not going to be using any of those. Usually you only want to use ReLU because those are like the most effective. And again, you can always change this to like sigmoid, but sigmoid is just not going to work well because sigmoid classifies in one or the other, so it's just not going to work well. Okay, so let me just put ReLU back here. So once we do that, we finally want to flatten. So this is all the convolutional related stuff. Then we want to flatten it all into a deep neural network. And from there, we want to create 2 dense layers. The first dense layer is just going to have a bunch of units, and it's going to be ReLU activation. And then we're just going to have 1 as the output neuron, because we're either classifying is it a horse or a human. And this has to be an activation of sigmoid. Can anyone tell me why you think this would have to be a sigmoid activation function and not like ReLU? I'll give you guys a hint. It has to do something about what are we trying to predict. So we're trying to predict either horses or humans. So do any of you have a remote idea? Yeah, okay, good job, Kavya. It's essentially because there's 2 options, either a 0 or 1. And sigmoid, what it does is it like, let's say we had a number that was like 250. The way a sigmoid activation function works is, oh, sorry, that's in black. So I made this blue. Let's say this was our graph. And we had something, so sigmoid essentially just compresses everything within 1 and 0. So any X value we have, it will just compress it into either a 0 area or a 1 area so that it's a binary. And if that didn't make sense, just know that you always want to use a sigmoid activation function if you're trying to classify between 2 different things. Okay. Yeah, and then, so that's why we add a sigmoid at the end. And then we finally want a compiler model. And so there's 2 different ways you can specify this. Like in the previous notebook, if you remember, we did it a bit differently. But this is usually like the common simple way to do it, where you just say loss equals what is the loss you want, optimizer equals what is the optimizer you want, and metrics equals, and then the like list of like things you want for metrics. And then this stuff is probably new, and this is called the image data generator, which is used for augmenting our images. And this helps us add all the data augmentation. So this is all data augmentation right here, rescaling, rotating, width, height, shifting, shear ranging, zoom range, like how do I zoom in and stuff. And we can also horizontally flip it. like fill mode to the nearest. This is more advanced. I won't explain it. But these are all different ways we can augment our data. And we do a similar thing for the validation. Actually, sorry, we do not do it for the validation, my bad. We only augment on our training data, but we never augment on our validation data, because the purpose of data augmentation is so we can have more training images, not more validation. Okay, then we want to use this flow from directory thing that comes with image data generator, and we just want to, like, if you remember, we had that source directory with all the training images. We want to resize it, specify a number of branches, and say what is our class mode. And we do the exact same thing for validation, except we swap this out for validation here. You're going to see it says like found 127, found 256 images. And then this is just fitting the model. So we set the number of epochs here, set the number of validation steps, and we can also set the validation data in here. And the train generator. So this is essentially fitting the model, and we set it to a variable called history. And then we're going to be able to access different stuff from the history. And then this is just seeing like, how did our model perform? And you can see here that like the validation loss like started to increase. And this, you know, is like a bad thing. And this is like where you could improve your model. Like you do not want validation loss to increase. You want it to start decreasing. So that's just like something to keep in mind. But you can see here, it looks like validation is like generally going upwards, even though it's not the highest. And so this is when you know like, oh, our model's not doing that well. And that's when I want to perform some hyperparameter tuning or like doing any of the techniques I mentioned last class. Okay, so that's pretty much it. I've gone a bit over my time, but if you have any questions, let me know. I'm actually going to be like leaving the Zoom room and letting you, Raj, take over. So just like, I'll give you guys like a minute to ask me any questions. So like 12:53, and if you don't, then I'm going to head out. And also share the final notebook with you guys so you can view it. Okay. So that's the notebook. Just feel free to look at that and look at all the concepts I've taught so far. Okay, so it looks like no one has any pressing concerns or issues or questions. So I think I'm just going to stop the share and just give it over to you, Raj. So you, Raj, go ahead and start teaching.
Hey guys, my name is Yuvraj, and today I'll be teaching you guys about two things. One would be sentimental analysis, which would be a much easier topic. It's going to be a quick basic introduction to recurrent neural networks, and then we'll go more in depth by using recurrent neural networks in order to predict stock prices in the future. So let me start sharing my screen. One second. One second, guys. Let me quickly change the setting on my computer in order to get the screen share to work. I'll join back in 2 seconds. One second. Okay, I'm back. I think I can screen share now. Okay. So we're going to start off with the slides on sentimental analysis. Google Slides. Okay, so here's the slides on sentimental analysis. And so essentially, what is sentimental analysis? So as we know, we can just read through passages and understand the sentiment of what someone's trying to say. So like if I'm writing something good that happened this week, the reader could be like, yeah, clearly Yuvraj had a great day. However, that's not the same thing with computers, and computers can't just have that type of emotional sentiment towards what someone's trying to write towards them or what they're trying to read. So essentially, sentimental analysis solves this problem by utilizing natural language processing, also known as NLP, to recognize keywords. These keywords help the computer classify the emotional status of the text. So the first step we have is tokenization. And tokenization takes the text that we give the computer and breaks it down to individual words and characters. So if we have the sentence, the food was great, where the computer is going to break down each word and character here. So we'll just put it right here. The food was great. And then we'll have the exclamation mark at the end. So this allows the computer to organize all the words and read them individually and respectively. And then step 2 is clean the data. To clean the data, we must remove all characters which are not words. In this case, it will be the exclamation mark, because the exclamation mark could give us a sentimental analysis like help. However, it's not in a natural language processing because it's not a word in the English dictionary. And then we're removing stop words. And basically stop words would be like, one second, hold up. Stop words are words which don't really contribute to the sentiments of the text, such in this case would be the and was, because I mean the and was are pretty like normal words, and like it's not telling me if I'm saying it negatively or positively. So now we only have food and great left. And then the last step is to be classifying. And in order to determine whether the word is positive, negative, or neutral, we must process the words in the text using natural language processing. So we compare the words with commonly used words and determine the polarity score. So essentially what natural language processing is like a collection of words, such as like the Oxford Dictionary. And what NLP does is it compares the words that we give it to it, and it compares them to words in the dictionary or words which are provided in the NLP. And essentially here we have the classification of food, which would be 0, meaning the polarity score of food is not much. It's not positive nor negative. However, we have great, which gives us a +1 polarity score compared to the other dictionary words, meaning that that's a positive score. So we can go next and we can calculate it. And to figure out the polarity of the text, we'll just add the classification numbers of the words. And here we have 1, which was from great, and then 0, which was from food, which gives us +1. And since the polarity of the text is greater than 0, the text is a positive statement. So it's a pretty simple concept. However, now we need to essentially put this into code, and that's what we did in this Python code over here. Go all the way up to. So essentially in this project, what we did was we took Twitter tweets and we analyzed them in order to determine each tweet sentiment. And towards the end of the project, we visualized the tweet sentiments and plotted them in many visual aspects in bar graphs and scatter plots. So essentially first we have to do is put in all the libraries, and we used a plethora of libraries as we can see here. And the first library allows us to access the Twitter API. This library is Tweepy, and probably the most important library in this whole project is TextBlob. And TextBlob is the Python library which allows us to process textual data, and this will help us determine the sentiments of the tweets. As I had said before, natural language processing takes words and text and compares them to words which are commonly used or keywords in the English dictionary or whatever dictionary you're using in the NLP. So, and these are a plethora of other libraries which we're going to use to visualize everything. So here we're going to import the libraries, and I've already ran all of this code, so all the results are here. So we're just going to go step by step, block by block. So once we've imported the libraries, the next thing we need to do is we need to gather tweets from Twitter. So we must communicate to the Twitter API, and I'm pretty sure everyone knows what APIs are. So like, if anyone wants to answer, like, can y'all write like a quick comments on what APIs are. So like I can see if everyone knows them. Like anyone want to answer the question, like what is an API? Exactly, yeah, Kavya, that's correct. So essentially an API is a way to connect to another data source. And in this case, we're gonna be connecting to the Twitter API, and we're gonna be gathering tweets from Twitter, which is the next data source that we're gonna be using. So I went ahead and created a Twitter developer account, which will give us access to a consumer key, a consumer secret key, an access token key, and an access token secret. And all of these keys seem pretty complicated and long. However, they're just simple passwords in order to help us access the data source of Twitter so we can extract these certain tweets. And then after assigning our Twitter keys and tokens, we'll run a program which will give us access, basically authenticating ourselves into the Twitter API. Once we have gained access into the Twitter API, we will extract 100 tweets. I mean, you could do as many tweets as you want, but in our case, we can do 100 tweets. And in this case, I'm extracting tweets from Bill Gates right here, screen name Bill Gates, and we're going to take a count of 100 tweets in English. And then for our data frame that we're going to be using, we're going to be taking we're only going to display 5 tweets just to show that the program worked of extracting these tweets. So here we have the five recent tweets, and such as the first one, the impacts of COVID-19 are driving worrying increases in malnutrition and health outcomes. However, these are clear actions that can be taken in both the near and long term. And here's a link of something Bill Gates must have typed into. And that's basically, these are another 4 other tweets which are recent. And then we're gonna basically organize these tweets using pandas to put them into a data frame so we can see them in like a more like clear view. So here we have tweets, just an organized way to see them for a user. However, now if you look at this, we have a bunch of tweets, but we have many things, such as if you look over here, we have RT standing for retweets. Now our natural language processing can't process RT, or it can't process the @ in tweets. So hence we must remove them using cleaning the text formulas. So that's a good question. It's not just positive and negative, it's also neutral. So so the sentiment can only be categorized as positive and negative, or is it on a spectrum? It's okay, so it is on a spectrum of polarity. However, we can base that and scale that polarity off of like a greater than or less than formula, and it is a spectrum. So like you could have like a 0.25 polarity, which is technically greater than 0, meaning that it is a positive tweet. However, maybe that's not as positive as a polarity of 0.5, which is clearly higher polarity, meaning it's a more positive tweet. However, it still lies under the sentiment of a positive tweet. So yeah, in hindsight, it is a spectrum. However, we can also make it easier by telling you if it's positive, negative, or neutral using greater than or less than. So in this function, we're going to be cleaning the text. Right here, we're going to be removing the @ and then removing the hashtag symbol and removing the retweet and removing hyperlinks from the tweets, which allows our natural language processor to correctly process the tweets in order to determine the sentiments directly. And this is the sentiment once it's clean. As you can see, we have 100 tweets right here, and none of them have the @ anymore, the hashtags, or the hyperlinks. So this is clean, and now we can process all of them. So in order to essentially pick up the sentiment of the tweets, we have to calculate the polarity of the text. And here we'll create a function which will calculate the polarity of the tweets and tell us how subjective each tweet is. In order to calculate the polarity, we use a text blob library, which will process the text and will remove stop words that do not influence the sentiment much. Actually, we already removed stop words. No, we didn't remove stop words. We removed the @ and retweets. So essentially, TextBlob will compare it with the NLP, the natural language library, and then it'll calculate the polarity. So here we have the get subjectivity function from TextBlob, and it's going to bring back the sentiment subjectivity. And then same thing we're going to do with the polarity. And we're going to basically put this into a data frame in order for us to better see it. So here we have a tweet. And here's the subjectivity of the tweet, and here's the polarity. And as you can see, this is the perfect one, meaning it's a positive tweet. And in another case, we can see here's a negative tweet. I don't know why this would be a negative tweet, but according to TextBlob, it is a negative tweet. Then this is just for fun, but you can potentially create a word cloud on the words which are used the most in all the tweets. And here we have will, vaccine, coronavirus, work, world, COVID-19. So as you can see, these tweets are really generalized around what's happening in the world currently. So coming back to the question you asked, the polarity score is just a number. It does not specifically tell us whether a tweet is a positive, negative, or a neutral tweet. And in order to do this, we can set up an if-else statement, which tells us whether a tweet is positive, negative, or neutral by analyzing the tweet's polarity score. So we're given a spectrum based on the polarity score, and now we just need to categorize the spectrum or each polarity in the spectrum into the polarity of positive, negative, or neutral. And here we have the guide right here. And if the polarity is less than 0, that means the tweet is a negative tweet, according to TextBlob. And the polarity is equal to 0, that means it's neutral. And polarity is greater than 0, that means the tweet is positive. So here we're just going to run that get analysis score using the if score is less than 0, negative, and then et cetera, exactly the same. So here we have a tweet. The polarity tweet is 0.1, which is greater than 0, meaning it's a positive tweet. And here we have a neutral tweet because the polarity is 0. And basically we have essentially categorized it. And that's how it works in general. The TextBlob library or the natural language library that you will use will compare it to a set of keywords which are already in it, which would be millions of words that it has. And TextBlob is not the only thing you can use. TextBlob is a pretty easy one you can use. However, you can also connect this to like a Microsoft API from Azure, or you could use a Google API, or you can even use an AWS Amazon Web Services API, which consists of a plethora of words that you can compare with. Okay, and here we're just gonna go ahead and print all the positive tweets. So here's all the positive tweets. And let's take an example of a positive tweet. Thank you for the conversation and partnership. Combating the pandemic requires global collaboration. India's role is a key as the world tracks to minimize social and economic impact and pave the way to the vaccine, etc. So that's clearly a positive tweet, and all these are positive tweets according to TextBlob. And then here we can also rank the negative tweets from 1 all the way to last. And in order to visualize the polarity and subjectivity of each tweet, we can create a scatter plot. And here we have a scatter plot, and we can see that there are more positive tweets because there's more dots in higher greater than 0 than the less than 0. And the less than 0, there's less tweets. So clearly we can make an assumption and a conclusion that Bill Gates' tweets are predominantly positive more than negative. And here's just the percentage of positive tweets from when we extracted this data and calculated it, and that's 67%. So our scatter plot is telling the correct story of more positive tweets. And here we have the percentage of negative tweets, which is 17%. And then we can also create a bar graph showing us how many positive, negative, and neutral tweets there are. So essentially, this is a really easy, straightforward example on how to use sentimental analysis and a quick basic example of recurrent neural networks. However, okay, quickly, before we move on to the stock price prediction, anyone have a question on this so I can quickly go over it? Any questions? Nope. Okay. So then I think I can move on to, oh, why is Siri activated? Okay, we can move on probably to recurrent neural networks. So RNN, in theory, is basically, get to it. So what are neural networks? Let's start with that before we get to recurrent neural networks in specific. Neural networks are essentially a naive imitation of how our brain might operate. Our brains are essentially a bunch of neurons connected to each other in an enormous interconnected network. The connections between neurons are called pathways. These pathways relay information to each other and become stronger as more information passes through them. So as an example, let's say we touch a sharp knife. The nerves in our hands, or where we touch the sharp knife, transmit the info that we just touched a sharp object, and the neuron sends a signal back to the nerve to move the hand away as soon as possible. And over time, our neurons learn and become trained to make better decisions ahead in life. Just like that, we can create a neural network on computers and train them. So let's say as a child, you touched a hot burning pan, a boiling pan, and you suddenly moved your hand away because the neuron sent info sent, info through the passageway, through the pathway to your hand to move. This way, now the neuron knows, and now your brain is trained to not touch a boiling pan again. Just like that, we can train neural networks in order to create imitations of our brain or create what we're trying to get. So here we have our components. So neural networks consist of many nodes, which are also known as neurons, if you talk in terms of brains, and many layers. Each layer can hold any number of nodes, and a neural network can have as many layers. As you can see, these nodes, layer 1, are connected to each node in layer 2. So layer 1, each node is connected to each one of these nodes in layer 2. So all of them are interconnected. These are also called the weights between the layers. These networks also consist of hidden layers. And hidden layers basically perform like computations in order for like the pathways to like communicate between each other. So how do recurrent neural networks in specific work? So we talked about neural networks, but how do recurrent work? So artificial neural networks and recurrent neural networks both fall into deep learning. However, artificial neural networks do not have an internal state. Hence, we do not use them to process sequential data. So basically what this means is that artificial neural networks or normal neural networks don't have a memory, but recurrent neural networks do develop a memory, hence we can do sequential data. So using recurrent neural networks, we can process the sequential data due to the fact that neural networks perform the same function for each input given to it. This way, the network can take multiple inputs, and this multiple inputs can train the neural network for it to create a memory of what to do. So example, how old are you? How will be inputted into the network first, then network will perform the same for are you and the question mark. So that's sequential data because we have an order. We have to input everything in order of the sentence. First using how, then are, then you, and then the character of the question mark. That's why we have to use recurrent neural networks because they're on sequential order. So a drawback of recurrent neural networks in specific is that they consist of short-term memory. Every time new data is inputted into a node, the old information gets morphed. So as you can see in this graphic, each gradient of the color varies. So if we see here, if you can see my cursor, this like dark like teal color is much smaller than, let's say, compared to this orange color. That means that this dark teal color was inputted into the neural network first, and then all the other ones were inputted sequentially afterwards, which means that this is getting morphed. So the color with the least space is the first information inputted into it, like I said, and every time new information is added, the older information gets smaller and morphed. Eventually, the information will get completely morphed, deleting the data. So that's a drawback. However, we do have a way to combat all of this, which is LSTM, or long short-term memory. So in order to combat the short-term memory drawback of recurrent neural networks, we use LSTM, long short-term memories. And LSTMs are essentially advanced versions of RNN with minor tweaks to overcome the problem of short-term memory and learning long-term dependencies by using gates. And gates are a tensor operation that can learn the flow of information, and thus short-term memory is no problem for them. So essentially, to like simplify what this is that long short-term memory has gates, which basically like they train the neural network on what the data is doing or like what data is being inputted into them, so that the neural network doesn't need to learn each time. It can store what it has just learned from the first time it's been used, and then it can keep doing that again and again. Going back to what I said about touching a hot pan. Instead of touching a hot pan and realizing it's hot every time, you touch it once, and then you realize, okay, it is a hot pan. Your brain sends input, it's a hot pan, we're not gonna touch this again. So that's basically a recurrent neural network in theory. And now what we're gonna be doing is gonna be playing a Kahoot, so about recurrent neural networks, and then we're gonna go to the stock price prediction program. So just join this Kahoot here. Give it a second. Y'all can join this 992-2752 on Kahoot, and we can play this game. Potentially just take out a phone, which you have with you, or just open a new tab. Yes. on, guys, we have 10 participants, and I'm pretty sure only 2 of them are mentors or hosts. So I think I need like good 2 more, 2, 3, 4 more on this Kahoot. Everyone, please join. I'll give till like, it's 4:16 right now. I'll give till like 4:18. And I'll start the Kahoot. Is there no one else who's gonna join? It's like 1 or 2 more people. All right, that's fine. I'll start it then. So we have a battle between 4 people. Okay. Pretty easy question. Okay, so we discussed this, and if we quickly go back to this slide over here, not this one. If we go back to this slide over here, we talked about how sequential data can only be used in recurrent neural networks because this actually looks at how order matters. So yeah, recurrent neural networks is the correct answer. Good job for the 3 who got it. What the heck? Oh my God, go back to the Kahoot. Okay, next.
Wait, I can't see the screen share.
Okay, so artificial neural networks don't have an internal state. However, recurrent neural networks do have an internal states because they reoccur, which means it trains the neural network and gives it a memory. So to put false is right. Kavya's on a roll, and there we go. That's correct. I'm pretty sure Krish talked about this when he was talking about convergence on CNNs, on how there can be as many layers as neural networks, you decide, but it's usually based on squared. Lack of application. No. We talked about this, guy. Lack of memory is the major drawback of recurrent neural networks. However, we can use long short-term memory, LSTM, to fight this. Kavya is back at top. Mm-hmm. correct. Ecology, it looks like she's gonna win this. That is a pretty easy question. Okay, and the winner is Aditi, Avi. Kavya, great job, guys. All right, so now we're gonna move on to the last thing for today, which is gonna be a bit more complicated, but pretty quick stock price prediction, RNN. So we're gonna be using RNN to predict stock prices. And in this case, we're gonna be doing Tesla stock prices. And we're gonna be taking data since 2015 on Tesla stock prices and predicting them for the future. I mean, not predicting them for the future, but predicting them starting. You'll see what I mean. So first we must import all the libraries needed, which is like the math library, the pandas library to put the data in, and the NumPy library to process numbers here, and the Keras models, Keras layers, and the sklearning, which is going to be the main gist of the recurrent neural network. So first things first, we'll extract the Tesla data from Yahoo Finances using the web data reader, such as the pandas data reader. And here it is, starting from 2015 all the way to 2020 August. That's not August, but okay. So here we have now we're going to quickly plot the data which has been given to us from 2015 all the way to 2020. And as you can see, there's clearly a linear rise in the Tesla stock price. And now I'm just going to quickly go through this because we are running out of time. So quickly just skim through this. We're going to create a data frame based on the closed column. And essentially what we're going to do in these next couple of steps is train the data. So in your neural networks, you need to train the data in order for it to predict it in the future if that's what you're trying to do. So we're going to create the training data length, and then we'll scale the data and put it into an array as we have done over here. And this array will basically be a bunch of inputs given to the training set, and it's going to train the data. And now we're going to build the LSTM, long short-term memory model, which is going to, since we have so many inputs, we have thousands of inputs on stock prices since 2015, our recurrent neural network can easily forget. Because remember, if we go back to like the gradient gradually decreasing, as we see, there's so many, they're gonna like, eventually it's gonna get so morphed that the neural network will forget. So we're gonna have to put an LSTM model in order for it to keep the memory of the stock prices. And then we'll compile the model, and then we'll train the model, which this epoch does right here. And now we're gonna create the new training data set and then plot the data. So here we are. This is basically all of these is just reshaping the data so we can have it organized for the training. And essentially, basically what we do here is we're going to take the trained data and we're going to plot it. So as we can see here, this is 2015, and this is the gradual rise. And blue, so it uses the blue data to train itself. Then it uses, and the orange is the actual value of what happened, and then the yellow is the prediction. So as you can see, this is extremely accurate here. So we can see that the prediction is essentially almost online, just falling a bit short at the top. But yeah, and from what I was reading, that if you use this program in particular and do stock price prediction with recurrent neural networks, you can have accuracy of up to 96%, which is insane. And this also, a lot of like jobs in investment banking are using fintech, which is like financial technology, and creating like these types of models for big investment firms in order to help them predict stock prices of certain assets or companies in the future. And that's essentially what we did here. We predicted the Tesla stock price with almost like a 96% accuracy, and we were pretty accurate in it. And all we did was take the previous data from 2015 till mid 2019 and use that data to train our model of recurrent neural network and fed that data. And basically we got an output using our layers and nodes of the predictions, which almost matches our value. So yeah, that in gist of it, that is what stock price prediction using recurrent neural networks is. So if you have any questions, type it in the comments and I'll quickly answer it because we are running out of time. Any questions? Yeah, I will totally share the link to the Google Colabs. Thanks, Abby. Okay, so I think we should be done. So I'll probably be ending the meeting now.